This Late Night Linux Family podcast is made possible by our patrons. Go to latenightlinux.com/support for details of how you can join them. Support us on Patreon for access to ad-free episodes and early releases. That's latenightlinux.com/support. Hello and welcome to episode 136 of Linux Dev Time. I'm Joe.
I'm Amalith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. We were recently talking off-air about your favourite languages. Obviously, Kevin and Andy, you love Rust. So I kind of wanted to know why, but then I thought, well, hang on. Let's not just make this a Rust love fest. Tell me about some of the other languages that you like and why. And we'll get to Rust eventually. So Kevin, apart from Rust, what do you like?
There's a lot of different languages that I use daily. I would say things like Python I use all the time, and I love how fast I can prototype stuff out in Python, and that I have the option to both be strict with my requirements and use typing, or be rather loose with my requirements and not use typing. So that's something I find I always reach for, but there's a lot of other languages that I've used in the past as well, and there's aspects of the various languages that I've liked. I used to really like writing in C# back in the day, and that was mostly a lot of GUI-based programming, which C# makes very simple, along with a lot of data connections. But it kind of depends on what I'm doing as to which language I prefer the most or what I like about a different language.
One of the really nice things about Python is you can express yourself in ways that are very clear and succinct, and it can almost read like English, and there's not a lot of extraneous symbols and things that are intimidating looking.
One of the things that I've really liked about Python is you can have very succinct ways to say things, which in my opinion don't necessarily read super like English if you start talking about like list comprehensions combined with the like lambdas and things. But you can have a lot of code going on in a very short period of time, which is helpful for prototyping, especially because you can fit a lot of the code onto one page at once in a way that's still idiomatic to the language. So it's easier to kind of keep that context in your head, or at least for me it is. And I like that about the language, that it can be very dense, but still idiomatic.
And actually, an interesting point about that is that that's partly culture. It's partly like just the way people tend to use Python is that they don't care about ultimate performance, because some of the ways that Python makes things simple is that it does things in an inefficient way, but it's just really easy to say it. And part of why you can do that in Python is because like other Python programmers won't dead arm you or something.
It's also a language where there's a real strong culture around like the way to do things, and certain things should be done certain ways. Additionally, you have things like their PEP8 linters and Flake8 and all these different things that can format the code using Rough and PyLint and all these other things that you can use to really format your code, lint it in very common ways across the entire ecosystem that make writing it and reading it and other people's code very pleasant. Like it's pretty simple to read someone else's code just as it would be to read your own code. Like there's not a lot of variance between the different ways that people write Python. Now then, there's also things about Python that I dislike. And when you get into languages that allow you to have like a really strong runtime component, and you can effectively monkey patch parts of the dependencies, things can get very complex and confusing very quickly. It also allows you to use things that, or to create abstractions that visually are very easy to parse and read, as in like there's not a lot of syntax on the page, but what's going on behind the scenes is a ton of magic. So Python is really good at like hiding a lot of that magic, which is, or can be a good thing, but it can make using different dependencies or people's code where they want to use that magic a little bit more difficult unless you just already know what's kind of going on, or you dig down to see what's happening. And languages like that, I find, if you're sticking to the base language or to dependencies that you know really well, that's fine. But it does get a little bit more difficult because the sky is kind of the limit for whatever someone wants to do in that language. And you have to look a layer deeper to see if that's really what's happening.
But also, let's talk about the elephant in the room with Python, right? If you have a function in Python that's more than about half a page tall, you have no idea which block is which because there's no curly brackets to tell you.
That was one thing I was going to mention. I hate having to use my mouse or put my finger on my screen and trace the indentation guide up or down as I scroll through the code to figure out scoping issues.
I've heard it described both ways, where people will say like, oh, there's tools in your IDE that can, draw a line for the scopes. and that will help with collapsing and things. So therefore, we shouldn't care about it at the language level. We should be at the language level only caring about what's the path of least resistance. But in my opinion, like if you have to rely on a tool to make a thing more usable, like that's the line is not quite as clear cut for me at that point.
Yeah, I want to be able to email some code to someone and they can still read it.
What about the fact that it's interpreted? That must have pluses and minuses, right? Compared to something like C or Rust. Like you can run it really quickly. You don't have to sit around and wait for it to compile. But also when you do run it, it's going to run much more slowly than a compiled language.
Definitely. And I would say Python takes that extra flexibility to the maximum level, which is part of the stuff that Kevin was talking about. You can like really fiddle around with stuff at runtime. So it's not just that it's technically interpreted, it's that it really makes use of that to be really super flexible. But that also makes it a lot slower than well-optimized code in another language.
Yeah, it's all about trade-offs, and having that flexibility can lead to really interesting syntax that reads really well, but might have a lot going on behind the scenes. It can lead to like slower runtime performance. There's also like there is a lot of stuff that is implemented in C for Python, like down at the lowest level. So there are areas where Python can still perform really well because there's like a C module underlying it all. But having that interpreted layer, it can add flexibility, and it can also create other detriments. Like one of the other things too is like which version of the interpreter is found on the runtime system. And that can create a whole class of issues like detecting which version you're running on and enabling features left or right depending on which version you're on. Like there's all kinds of additional complexities that come in from having that runtime dependency.
Yeah, and that's another thing to talk about when you're talking about good things or bad things about programming languages, right? Like how do you deploy your program? Like how do you get that to actually run on someone's computer? And with something with a runtime like Python or Java or C# or Ruby, you've got to make sure that they've got the right version of the interpreter on their computer. And when I first learned Python, that was really easy because like all Python programs just worked on every computer or every Linux or Unix computer. And now they've completely destroyed that and no Python program runs on any computer ever.
And that's what led to the whole Python 2 to 3 fiasco, which is now, a decade and a half old at this point, I guess. I guess if the listeners aren't familiar with that, what happened was a lot of Python code ran in a Python version 2. And then Python 3 was released with some breaking changes. And a lot of things did not update to Python 3, which led to years down the line, programs only supporting Python 2, but then distributions and all things that control like the runtime environment, eventually moving to where they only support Python 3. And now you have this whole like kind of breakage where there's big pushes to update code to the latest version of Python, which just had all kinds of other crazy things that happened. And it's a whole series that played out over the course of like a decade and a half.
And we're all traumatized, and now we'll never ever change a version of anything again.
So Amleth, when we were planning this episode, I said, we can't just have this all be about Rust, and I know you like Go. We need to expand it to be a bit more than that. And you basically said, well, I don't really like any other languages apart from Go.
This is true.
So why?
There are a lot of languages I'm just okay with because I came from Go first, and I feel like it spoiled me very badly.
That's quite unusual to not learn something easier, simpler like Python first.
I mean, I'd written small short things in Python before and little bits of Bash here and there and HTML and CSS, but Go was the first sort of real language that I dug into and tried to actually make useful things in. And I find that it just kind of works with my brain better than most of the other languages. I find Go programs are easier to think about. Everything is right there on the page. And I've been working in Ruby a lot lately, and it feels like any tiny edit we make could result in crazy issues that we'll spend the next 2 days debugging because of some unseen side effect somewhere in another library. And you definitely have that with Go. I just don't feel like that happens as often.
That might be more of a side effect of a like interpreted language to ahead of time compiled language.
Mm-hmm.
And getting a lot of that feedback and type checking and all these other things that Go does up front, which can be the same thing can be said about Python as well. And it's something that I do struggle with in Python, especially large code bases that I'm unfamiliar with. Small changes have the ability to turn into runtime errors and exceptions due to something that I just wasn't tracking or was unrelated, and there's no way to catch that except for just really good testing. Whereas ahead of time compiled languages do a better job at least making sure the interfaces between things are correct or more correct. However, Go is one language where, much like Java, I think the ability to duck type or pass around like interfaces can also lead to a similar problem where people basically just erase the type and pass things around, and you don't really know that something was the wrong type until runtime.
So one of the things that people say is a really nice thing about Go is that it's very simple and you can learn the whole language fairly quickly. And one of my favorite languages, because of its simplicity, is Lisp. And especially I like Scheme Lisp because it's like the simplest type of Lisp. And you can learn the syntax of Lisp in literally half an hour. And if you want to learn the macros, maybe a day. And everything fits into that really simple structure. And that is an amazingly beautiful advantage. It comes with disadvantages as well because everything looks the same as everything else, which is sort of interesting, but it's great.
I really felt that when I first started programming Go, that you could learn it really quickly, you can get up to speed in it, and start using it for production stuff fast. It also has a lot of other things that I think it got really, really right. Like the ability to cross-compile with basically like no thought. It has very fast compilation. It results in a single static binary. Like there's all kinds of things that Go just does awesome. And I actually moved to Go from Python way back in the day and was like, this is it. This is the thing I've been waiting for. So it definitely has that allure. Where I think it has fallen down for me personally a little bit is it's one of those languages that is very simple, but it's hard to master. There's a lot that can go wrong at deeper levels. And there are certain things, depending on what you're trying to do, like if you're trying to write a microservice or a web service or something, Go is amazing at that. But then there are certain things that you try to do and all of a sudden like Go will just fall over. Like trying to fork a process in Go becomes very difficult. And like there's all kinds of weird things like that will pop up as you get to like certain levels of the stack, if that's what you're trying to use Go for.
Yeah, I think what some people really love about Go is it has this kind of no-nonsense approach where they will give you a way of doing the thing you want to do, and you're going to do it the way that they give you. And then it works. It's really quick to get the thing working, but it doesn't actually represent all the complexity underneath. And so you can end up in a kind of dead end where you can't do, like the abstraction you've been given doesn't match up with reality in some way that matters to you, and then you get a bit stuck.
Yeah, it's almost like it took the Python sort of PEP 8 and like the adherence to those types of formatting standards and like turned it up to 11.
Oh yeah,
which is awesome. It makes like there is legitimately, you cannot read somebody else's code and it won't look like your own. It's kind of great that way. And as you're writing, there's also some other concepts too, like the Go routines. That is pretty phenomenal to be able to just like magically on day 1 or 2 as you're learning the language also be exposed to and have something functional for like very asynchronous style programming. That is also a very cool thing that Go has enabled people to do very, very rapidly and very easily.
It's very cool, but it's also very opinionated, like I was saying. Like that is the way you do that. And if you don't want to do it that way, then you have to just do something, use a different language.
Very much so. It also like as you get into, I think, more complex programs, you can run into issues that are harder to solve, whether it be memory or just kind of depends on what you're doing, that are harder to solve in Go because of that exact reason. They're like, this is how we design the thing, and it is what it is. You get no say in it.
I think I really like how generally opinionated Go and its toolchain and its ecosystem are, because tools like Golang CILint and Static Check take those formatting guidelines and instead of turning them up to 11, turn them up to 20 or 30. You can, as you are writing the code, prevent so many classes of errors. And I don't feel like I get that with most other languages. It takes actually running the code, using it in the real world to find some of those issues.
Well, if you like that kind of thing, Amalith, have you ever heard of this language called Rust?
Have you met my friend Rust?
I'm told I would really like it. I just haven't tried it yet.
I mean, if that's what you like about Go, I feel like Rust gives you that more than Go. Well, I haven't used Go that much, but Rust gives you that in spades, right? You can really lock down what you mean, and then the compiler will enforce it for you.
Just describing your application through the type system and forces so many of the things that require external tooling for Go.
Well, to be clear, you can do that with Rust, and it does encourage that. But one of the things that I actually like about Rust is it doesn't make you do that. You can use types almost as much as you want or as little as you want with some bounds. But that is generally one of the things that I do enjoy, is being able to encode certain properties into the types themselves. And then when I do something dumb because I'm sleep deprived or tired or too much or too little caffeine, the compiler is usually pretty helpful and says like, that can't be used that way. And I'm like, oh, you're so right. Thank you.
I want as many guardrails as possible.
You're going to love Rust.
On top of just the language, Rust has another thing called Clippy. That is a linter, kind of like GoLint or something. And it catches a whole other set of class of issues. And usually these are more like logic issues, but it can also be performance issues. It can just be like code layout issues. Clippy, the bounds on Clippy are pretty phenomenal. Like the sky is almost the limit. It works at the AST level.
Mm-hmm.
And then there's another mode of Clippy that you can turn on called Pedantic, where it will legitimately tell you everything wrong with the code up front, and even down to like naming of variables and things that are pedantic. So those are off by default.
All right, time for the Rust Love Fest then. You've mentioned it quite a bit already, obviously, but what is it specifically about Rust that you absolutely love, Andy and Kevin?
Okay, so my overall summary of what I love about Rust is that you can express yourself very clearly, and the compiler enforces what you express in a helpful way. And one of the details of that we haven't talked about yet is the idea of ownership. So in a lot of modern languages, when you make an object, you get a bit of memory for it, and then you just forget about it, and the language itself will tidy that up later. And in Rust, you have to be extremely clear about who owns a piece of memory. And that makes your code clearer, in my opinion, and helps you realize that you've done stuff in your code that's ambiguous. And it also means you don't have to have a garbage collector, which is like a kind of technical performance improvement that you get out of that. But the real thing I like about it is the meaning. And that meaning is especially powerful in multi-process or multi-threaded code, where knowing about ownership makes it really easy to avoid some mistakes that you can otherwise get in multi-threaded code.
For me, it was that I was able to work on things that in C or C++ I probably would have not done, or done in a much less performant way, because I was worried about doing something wrong or just like endlessly debugging. And in Rust, I was able to go about it kind of the way that I originally wanted to, or the way that I thought would be more performant, because it feels like you have this like helpful friend as the compiler that is double checking. It's almost like having training wheels in a sense, but training wheels that let you go as fast as a motorcycle. Like it's a really weird way to describe it, but it lets you do things very, very performantly in a way that you don't always have to worry, am I creating the next CVE for my company? Without like, there are escape hatches and there's unsafe code and stuff too, but it lets you scope all of that stuff down to where you know where the areas that you really have to pay attention to, and then the helpful Rust compiler's got your back on the rest of it.
Yeah, so there's a whole class of mistakes you just can't make if the compiler lets your code through, and that is just it just makes you feel safe.
And that's not to say that it doesn't have downsides as well. Like there is a complexity portion to that, right? Like Rust does have a higher learning curve. Mm-hmm. I don't think the Rust learning curve is as high as the memes make it out to be, but it is higher than something like Go for sure. And additionally, there are a subset of programs that are safe that the compiler cannot prove is safe and will reject. So while they're trying to make that subset of programs smaller and smaller every day with improvements to the compiler and to the borrow checker, it is still possible that you will run into something that is technically safe that the compiler can't prove and will reject.
But also another thing about Rust, which I think the language pushes it this way, but it is the culture. Like I was saying about the Python culture, the Rust culture is kind of not that no-nonsense, I'll just give you what you need attitude that we talked about in Go. It's I will get this right. I will fully represent what's actually happening inside the machine, and I'll give you the power to manipulate that in a safe way. And so almost the first thing you learn when you learn Rust is the different ways of talking about strings. And there's like at least two, and both of them are confusing. And the reason is strings are like really hard, and most languages hide that from you, and Rust lets you have that power and gives you really powerful tools to work with them in exchange for having to learn all the different ways of expressing strings.
We actually just had this conversation at work the other day, and in Rust there is, I want to say something like no less than 12 different string types. Now, you're only exposed to about 2 of them in most Rust code, just like Andy said, but there are a lot of different representations because strings are very hard, text is very hard, and Rust does not hide that complexity when you need to handle that complexity. But one of the other things that I really think Rust got right was kind of like how I felt when I moved from Python to Go, and that I had these like single static binaries and compilation was fast, and it was like ticking all of these boxes for me. Well, Rust also ticked a bunch of boxes where it let me express things about the program at the type system that I wanted. It still gave me single static binaries that were great. It also added in like dependency management in a really, really beautiful way. And then it also included like all of the different linters and checkers and formatters. So like it just kind of was this culmination of all of this stuff that I had been wanting in a language while allowing my code to run as fast as C, but then also kind of feel like I'm writing a high level language, kind of like Go, or maybe not quite a Python, but like up to that level of like high level abstractions. So it's just like this kind of beautiful combination for me that has stuck, and I really enjoy writing it.
I was waiting for Rust for years, and I have proof of that because I have a whole series of blog posts about things I like in different programming languages. And I started writing like a fantasy programming language that I called Pepper that was supposed to like look like Python but compile like C++. And it had the ownership stuff that Rust has, except not as well thought through as that I was hoping to be able to code up. And obviously it's far too hard for me to actually do. And then suddenly Rust came along and it's like, oh, okay, it does that. And it does a load of stuff that I hadn't thought of. And every decision in it that I come across, I just think, yeah, that is the right decision.
Yeah, it's very rare that I will come across a decision that the Rust team or compiler has made where I just like disagree with it, but then also disagree with it long term. Like there are things that I have said like, I don't really agree with that particular path. But then as you go through the RFDs or the request for designs or discussion, I forget which it stands for. But as you go through these documents and you go through all the discussion that sometimes happens over the course of like months or even years, you realize like, oh, they've tried to account for every edge case and every use case with the goal of still being the zero cost abstraction, meaning the abstractions we give you, the high level abstractions we give you could not be implemented any faster, even if done by hand. So that's pretty phenomenal that you can get these really high level abstractions, but still have such great performance.
I tell you what I would change if I could go back in time. I would make the question mark bigger, like it's too small, you can't notice it.
Andy, I'm becoming increased that we work together because we also just had that discussion at work as well, where there was a bunch of early returns and I was like, hey, this is the question mark operator. Like you have a return at each one of these places we have to clean up. And they're like, oh yeah, it's so frictionless that it sometimes gets overused.
A little bit too frictionless, yeah.
And for those that are listening, the question mark operator is something where in Rust, if you have an operation that is fallible, it can fail or throw an error. You can append these expressions with a question mark. And what that will do is if the operation was a success, it just gives you the value of that operation. However, if it was a failure, it returns that failure to the caller. So it just kind of like bubbles up the error, which is a great little paradigm and it's super handy. I use it all the time, but it does have that effect that like just throwing a question mark on something is very easy, yet technically it is an early return. Also,
when you were talking about Go and you said it had fast compiles, and then you said, oh, and Rust gives me a lot of those things, I would not say that Rust gives you fast compiles. I mean, sometimes it gives you impressively fast compiles given what it's doing, but it's much slower to compile than Go in general.
Very much so. And while I like to attribute a lot of that to like LLVM under the hood, it definitely is slower than something like Go.
Go has unbelievably fast compiles. It's one of its main advantages.
Very much so.
I have noticed as an end user, with Go applications, it tends to be just one file that I download, like say a web server or something, and then just run it. Whereas it tends to be a little bit more complex with Rust.
Yeah, I think that's mostly a cultural thing again, right? Because Rust and Go can both compile to static executables. They're slightly different, but they're basically both able to run most places. But Go people tend to actually give you that executable. And often the Rust projects I've seen tend to just expect you to have Rust and compile it from source.
And I've never thought about it before, but I wonder if some of that is due to like trying to squeeze out the performance, like, hey, compile it on your machine and get the optimizations for your machine. Or if that's just a cultural thing. I've seen some projects that will provide a musullibc or musullibc, however you want to pronounce it, for Rust binaries, but that is also kind of like sidestepping the problem. So culturally, I think I would agree with that.
I think there's a general cultural difference in that Go developers make software for end users and Rust people make software for Rust people.
You might be right. Although there are some awesome command line utilities written in Rust, like ripgrep and FD and things like that. So there are some for end users. If you call command line users end users, then
yeah, I think sysadmins and stuff like that. That's fair enough.
But I agree. Rust is very interested in Rust. Yeah.
The easy deployment story of Go is a huge reason why I like it.
Yeah, and deployment is so overlooked and so important for all programming languages.
Yeah, you lot start talking about crates and stuff like that. Just like you lose me, man. Whereas just, all right, I download this thing, I run it, cool.
Well, at least to the deployment part, the crates shouldn't be coming into there. That's more of the dependency for compilation. But one of the areas that we actually didn't talk about too much with Rust at all was the testing. That's another thing that I think they just learned from things like PyTest and some of those other great frameworks. We're like, hey, what if we incorporated this almost at the language level? And, that this also includes things like benchmarking and things. So Rust was kind of a perfect storm for all phases of the development, at least in my experience.
And every decision they made was right, including how to structure that testing stuff. So I've taken an action from this, Joe, which is that whenever I make a Rust program from now on, I'm going to upload an executable that you can run on your machine.
Thank you.
I'm also going to double check my projects and make sure they have an executable.
Well, time ticks on, so we should probably think about wrapping it up. So unfortunately, no time to talk about JavaScript and how great that is and all the frameworks and everything. What a shame. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.